All right, we're recording. It's Tuesday the 14th, and yesterday I posted this thing about the picture day, and then it was immediately adjusted. Maybe I should delete that old one just so it doesn't mess anybody up. We're doing it on a different day now. So today I posted a new CodeHS, and this is the last one for the quarter. Okay, this is the last CodeHS thing I'm going to assign. It has an idea called functions, which we've used plenty of times. Input and print and range and round and a couple others that we've used are functions. But you can also make your own. You could put a couple lines together, give that a name, and then call it up later. So it's kind of like when you make a variable, you have some value and you give it a name, and then you can use that thing whenever you want. You can give that same treatment to a chunk of a few lines. By the way, if you happen to look up info online or YouTube videos or whatever, some computer programming languages call these procedures. They'll have like procedures and functions or different things depending on what they return as a result. In Python, nope, we call them functions. Don't worry about that. So if you're ready to work on that, cool. But if not, that's fine. My plan is to assign all this stuff this week and then work on it for the rest of the quarter. So later in the week, I'm going to assign one more project. And if you do it, then cool. But if you wait a week and you're doing other stuff and you do it closer to the end, that's fine. I want to make it so that everything is there well in advance. And if you're ahead, if you're behind, you're fine either way. Okay? Let's get up the calendar just to keep this fresh in our minds. We have 3 weeks. Okay? 3 weeks, counting this one, and then fall break. And I want to be done with no rush. You know, I don't want to like assign something in the last week and then have everybody get stressed about doing it and me get stressed about grading it. I want to assign all the stuff and then have some time to get there. So this week I'll assign this and one more project and we'll do that stuff. If you did Unit 5, that's awesome. If you're still on the middle of it, that's okay. If you did the deck of cards project, that's awesome. I saw a few turned in over the last week, and I haven't checked today, but I'll probably have a few more. That's awesome. If you want to work on it today, that's fine too. I wanted to go over one example of something from Unit 5 that might help with that, and it might help with the deck of cards thing. It's also one that I haven't done already. So let's take a look here. I believe it's in, yeah. So this one, 546 rolling dice. I haven't gone through this one on the board or in a video, and I think it's really useful for learning the ideas of this unit and learning the ideas of the deck of cards thing. So it says write a program that will print out all combinations that can be made when 2 dice are rolled. So it's going to say 1, 1, 1, 2, blah, 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 and then 2, 1, 2, 2, etc. They say combinations, but if you're really sharp and you're remembering math class, you might say, actually, that's permutations, not combinations. Because if you do like 1, 3, later you're going to do 3, 1 and count them as separate things. But who cares? So we're going to have 36 lines. 6 for the first die, 6 for the second. All the possible outcomes, right? Now, let me delete all this and type it ourselves. That doesn't mean we're going to have 36 lines of code. We're going to have quite a bit less. Because the only reason we do this stuff the only reason we have computer code in the first place is to save us time and save us work. So if we had to type print 1, 1, print 1, 2, print 1, 3, it wouldn't really help, right? So I'm going to go a couple lines down and start how we might get this. We know that we're going to print our first die and then our second die. So I'm going to say die 1, which I haven't created yet, but you know, we'll get there, plus comma plus die 2. That's the print line that's going to happen. It's going to happen a bunch of times, but we only need one print line in the whole thing. And so wrapped around that, we're going to have some loops. Loops meaning, hey, we got this line, we're going to do it a few times. Would somebody open the door, please? So I'm going to go for die 1 in range 6, and then I'm going to go for die 2 in range 6. And if you were looking, you might have seen that the title of this section was called Nested Control Structures, meaning one inside the other. So I'm indenting to make it so that one is inside the other. That's sort of like, hey, we're going to do the first die, lock that 1 into place, and then cycle through all the others. Then we're going to do the 2, lock that into place, cycle through the others. Now, if I run this, it's almost going to work. It's almost going to be perfect. Let's see what happens. Whenever I give people advice, like when I'm sending them comments on their projects or whatever, I always say, do what comes to your mind as like the first step, and then fix it later. You don't have to write everything perfectly from top to bottom. When I thought of this idea, I thought, yeah, that makes sense to print them with the comma and then to loop through. But there are actually two problems with this. However, it's good to do something, hit run, do something, hit run, do something, hit run. You don't need to like perfect it before you ever try, because that requires 10 different things floating in your head instead of just 1 or 2 at a time. This says, hey, we can't do the plus operation with this guy and this guy because they're different types of guys. Die 1 is an integer because it's going through the range, and the comma is a string. So I'm going to go str around these guys. There are other ways to do it, but that works, and that's what we've seen so far. So if I do that and hit run, it's going to be one step closer to perfect, but not quite there. It does print 36 lines. We're not counting, but trust me. And it does have the right numbers, except it starts at 0 and goes to 5, instead of the way a die works in real life, it starts at 1 and goes to 6. And that's because when you do the range function, you tell it how many, and it counts the way that computers count, which is 0 to 5 instead of 1 to 6. If you have a list of things in Python, then they're going to be numbered like 0, 1, 2 instead of 1, 2, 3. And in general, that's just the way counting works in a lot of computing situations. So I could say +1 inside of here, but that's kind of ugly. It's hard to read because you have to hold a lot in your head when you're reading it. So what I'm going to do instead is change this to 1, 7. So that means it's going to start to 1 and go almost to 7, not quite. It doesn't include the last guy, just like when I said 6, it didn't include 6. And so now when I hit run, it's going to do it. Slowly, but it's going to do it. And if I hit check code, it's going to love it, give me some green. Now, the reason why I showed that is because, A, it's part of Unit 5, and if you're on Unit 5, you want to get that idea. That idea applies to other ones too. B, I wanted to show how you write your code. It doesn't have to be in order. It doesn't have to be perfect. You do the idea, then you hit run, then you see what happens. You make a change, you hit run. And we had to go through a couple steps. And C, the reason why I'm showing this is because it's really similar to the deck of cards project. When you're showing how 2 dice might go next to each other, that's the same thing as when you're showing like 2 of hearts or jack of clubs. You're mixing all the possibilities of one thing and all the possibilities of another thing, and then you're printing them out. So when I have seen people turn in the deck of cards stuff, some of them were great, some of them I sent back with changes, and I'll look at more. But it is the same core idea. Yeah, question?
So when you have all those, how do you change them in their output to names? Like, since in the deck of cards project, you have to name every type of card. So once you have those numbers listed in the output, how do you change them to the...
Yeah, okay. Good question. If you're watching the video, I got a question that said, hey, but on the deck of cards, it's one extra step. We're not just saying numbers, we're saying sometimes a number, like the 3 of clubs is a 3, but you have to say the club, and you have to sometimes say jack or queen or whatever for the name of these guys and not just numbers. And luckily, on the deck of cards thing, I posted 2 videos about that. The first one is just an intro where it's kind of this stuff, but then the second one says, hey, here are some ways that you might get those names in there. So I don't want to do it all over again in this video, but I will show one quick thing. Is you could simply just say like if die2 equals 4, die2 equals Bob, and then instead of 4 it'll say Bob in all these. Okay, so that is one simple way to do it. You don't mess up the loop, by the way, if you change it from a number to something else. It's not like actually doing +1 to the current iteration. It's making the whole range before you even start and going to the next one. So if you want to do that, you can. If you want to see other possibilities, check out this video in here. When I was looking at my YouTube thing, I saw the views on this were pretty good, so some people had checked it out last week, but who knows. That's it for now. I want to stop this video before it gets too long, but the point is you can work on Unit 5, you can work on the deck of cards. If you happen to be done, work on the functions, and then later in the week I'll post one more project that uses functions, of course, and it'll be your last thing for the quarter, and we'll have 2-ish weeks after that to do it. So even if you're behind, you have time, and if you're ahead, you can get it and relax, or you can get it and look ahead to Unit 7, or you can get it and ask me what you can do, and I can give you some little fun project. We'll see. Thanks.